Hey, Jody here with weldingtipsandtricks.com. We're going to be doing some MIG welding overhead today and doing a multi-pass T-joint because that gives a lot of practice. Previously we did a multi-pass T-joint drill on the bench on the table, and then we did one vertical uphill. Now it's time to put this same joint overhead, get practice on that. It takes a little bit of material, you get a lot of practice. Here's the thing about overhead welding. Because it's overhead, you got gravity that will try to pull that puddle down. Because it's overhead, you're going to have a tendency for your arms to drop down, and that's going to have a tendency to make you hold a longer stick out than you should on MIG welding. So let's talk about three things that make more difference than anything else MIG welding overhead. Number one, have that machine set almost as hot as you would if you were welding it in front of you on the bench. I know that doesn't make sense to a lot of people. They think you should turn the machine down for welding overhead. But if you really weld really hot in the flat, maybe you should turn it down a little bit. But all I'm saying is if you turn it down too cold, it's just going to pile up and droop overhead. You need to take advantage of that arc force on a good hot arc and a good short stick out to drive that bead up in there and make it spread out and make it penetrate like it's supposed to. Okay, so number one is have that machine set, I'd say a good 85 to 90% as hot as you do welding flat in front of you. And number two goes along with that, use a short stick out. And what I mean by short stick out is ½ inch or shorter. If you use too long a stick out, what happens is that portion of wire sticking out between the contact tip and the puddle heats up from electrical resistance and it melts off soft. Melts off, it piles up. Doesn't drive in there, doesn't give you a good crisp arc. It doesn't give you a lot of arc force. You need that, okay? Well, let's take a look at what happens when you weld at a marginal setting along with too long a stick out. This is what I'm talking about when I say marginal setting. 19 volts, 250 inches a minute. I would use this to weld vertical uphill, not horizontal, flat, or overhead. So, take a few dry runs here, and then we'll use a long stick out right here, about a 3/4 inch, and if you're paying attention you can see it actually lose shielding gas along with just mounding up and looking really cold. Now I turn the shielding gas up just a little bit and still got a problem of it being cold and kind of crowning up just because it's not punching in there. It's just laying on the surface like a caulk bead, and that is a problem if you set MIG too cold on overhead. Now, getting a close stick out means making sure that contact tip is about flush with the tip of the nozzle. That can be a problem. Sometimes that tip is recessed back in there and you got to make some adjustments to get the tip about flush or maybe even sticking out a little bit. Alright, same settings here but with a close stick out, like ½ inch or closer. Much different. Much different. Still not as hot as I would like to weld on this joint for overhead, but way better. Now I've turned the volume up here. Let's just listen to this. Okay, the third thing is gun angle. Don't get crazy with gun angle. Whether you push or pull, and both work. If you're pulling the puddle, only use about a 5-degree pull angle. If you're pushing the puddle, try to shoot for only about a 5-degree push angle. Also, if you want to shoot for just holding it 90 degrees, dead nuts 90 degrees, that'll work fine too. With that helmet down, you're not going to be dead nuts 90 degrees anyway. You'll be a little bit one way or the other without realizing it. It'll be fine. Before we start welding, I want to say thanks again to Triangle Engineering for providing this weld test stand. Also, they have weld test plates and pipes that have heat number traceability on them and all kinds of things like that for testing welders. But they provided this weld test stand for me to do these videos of out of position stuff like overhead, vertical, and also I'm going to be doing some 2G, 5G, 6G pipe in the near future. trieng.com. This is the settings I use, and I left the volume on just so you can see how loud the fan is on this Thermal Arc Fabricator 252i. Here in the first pass, I'm going to try to hold pretty close to a 90 degree or maybe just a slight push, but pretty close to a 90 degree angle. Let's do that. I'm actually so close that I'm almost bumping the edges of that nozzle on the members of the T-joint as I move it around. And you want to keep a close stick out. That makes a big difference. And also I'm trying to stay on the leading edge of the puddle. Staying on the leading edge of the puddle is what makes all the difference in MIG welding, especially short circuit. Okay, well that was one pass, the root pass. There are other ways to do it, like if I was pulling with a slight angle, I might use a slight oscillation like this, kind of tracing the front edge of the puddle, keeping that arc on the front edge of the puddle. There's also other ways to do it, just like basically just keeping it good and tight but dragging it like this and maybe hitching forward 1/8 of an inch and then pausing. That works pretty well as well. Also, just using a little bit wider oscillation can sometimes prevent the crowning that happens if you're just dragging a bead overhead like this. Sometimes it crowns up quite a bit. If you use a little bit of a motion like this, spreads it out a little bit, as long as you stay in the front edge of the puddle and you keep that stick out distance really short, you can wind up with a decent looking root pass that's easier to weld, that's easier to stack beads on top of. And what you want to do with that second pass, you want to stack it about halfway over to maybe 2/3 over the first pass. And that's going to look something like this. It's hard to see where that bead is going in relation to the first bead, but I'm trying to go at least halfway and maybe even 2/3 over top of the first bead, kind of centering up on the toe of the weld, so to speak. Okay, now that leaves me with a situation like this, roughly maybe 1/8 of an inch of that first bead visible, and this bead goes in there just a little slower than any of the rest because I'm filling in a little nook, a little groove. So that looks something like this. You can see I'm traveling along just a little bit slower, pausing long enough to make sure I don't have any undercut on the top edge of that bead, and trying to overlap the bead under it by pretty much exactly halfway. Main thing is staying on the leading edge of that puddle. That's what makes it get penetration. Now you can see that steam coming off of this. That's because I dunked it in a quench bucket. Now a little caution here, dunking it in a quench bucket is strictly to make the training time efficient, where I don't have to wait and let it cool. It's not a good practice to get into. It's not something you want to do on actual parts on carbon steel. It's not something you want to do on any test you're taking on carbon steel. You want to let it cool naturally or slow cool. Here's what happens when you weld on it before it's cooled down. You see that second bead there starts to crown and sag a little bit. Same amperage, same settings I'm using, but it just started to sag because I didn't let it cool off enough. Okay, well let's finish this thing out. I'm going to speed everything up here to super fast motion, because from here on out it's pretty much the same deal. Just stacking beads halfway over top of one another. And of course I'm stopping it periodically and dunking it in the quench bucket. Otherwise it would just get so hot, too hot to handle. It wouldn't react the same. The puddle would get much more fluid and it would be like welding hotter. So I dunk it in the quench bucket about every 2 beads so I can keep going and make good use of my welding time instead of waiting and letting it cool off time. And there you can see lots and lots of beads, lots and lots of practice, and that's the setting I used with 035 ER70S6 wire. Well, that is it for this week. Hit that subscribe button if you haven't subscribed yet. Visit the store at weldmonger.com or click the visit the store button, and we'll see you right here next week.